Hi, alright, I'm going to explain how to do the first problem on the mass-to-mass practice worksheet. So this is the first stoichiometry problem we have talked about in class. If you look on the website, you can find this worksheet and be able to complete the problem. So our first step is to write down what we know for the problem. Our problem is we've got this chemical equation, 2KFO3 yields 2 moles of KF plus 3 moles of oxygen. And we want to know if we have 122.55 grams of KFO3, how many grams of KF are produced in this reaction. So, the first thing we'll do is we're going to write down what we know. We start by writing down the mass of KFO3. We know what that mass is based on the problem. It tells us it is 122.55 grams. The next thing on your paper that you'll see is the mass of KF. Well, that's what we're going to solve for. We don't know that yet. So we're going to I have a question mark there to show that's what we're looking for. Now, there's several things that we need to figure out to be able to do this problem. So the first thing we need to figure out is the molar mass of KFO3. So to figure that out, we'll do the mass of K plus the mass of F plus 3 times the mass of O. So if you want to take a minute, figure that out off your periodic table, and then I'll give you the answer. Okay, hopefully you paused it and figured out that the answer is 106.1. So that's grams. All right. The next thing we need to figure out is the molar mass of KF, since those are the two compounds that we're actually looking at. Molar mass of KF. And we're going to do the same process that we did before with the KFO3. We'll take the mass of K plus the mass of F. And when you add those two together, well, I'll let you do that, and then we'll see what you get. Okay, hopefully you got 58.1 grams. Okay, so let me erase this here. Next thing we're going to do, or the last thing that we need to start with, that we need to gather before we do the problem, is we need the mole ratio. Okay, so on your paper I have it set up so you already know which one should be on top and which one should be on bottom. Okay, so if you're looking at your paper, you'll see that you have moles of KF on top and moles of KFO3 on the bottom. I'll explain why it's set up this way later on here. So the way that we find the mole ratio is to look at the coefficients in front of each of those formulas. In front of KF is a 2, so that tells us there's 2 moles of KF. And then in front of KFO3, we also have a 2, so there will be 2 moles of KFO3. In this case, they happen to be the same number. Many cases, they're going to be different numbers, so just keep that in mind. You find this mole ratio based on the coefficients in front of your compounds. Okay, so that takes us through step 1, writing what we know, gathering some information. Okay, the next thing we need to do is make a map figure out where we need to go to figure out this problem. I'm going to put in a little section here looking at the diagram and pointing some things out. Try to hold this steady so that you can read it in the video, okay? We are starting with a mass. That was the 122.55 grams of KFO3. And we want to end up with how many grams of KF. So this diagram shows us that the only way to go from mass to another mass is to go through the moles here. So what we have to do is we have to go from mass to moles, and then mole to mole, and then mole to mass. Alright, if you can read this, it says here that we'll need the molar masses to go between the mass and mole, and then we're going to use a mole ratio to go between here. So, alright, back to the board. Okay, so we looked at the diagram. Now I'm going to write it out. So your diagram, this is step 2. You see that there's the mass of KFO3, and then we're going to go down to the moles of KFO3, and then we'll move to moles of KF, and then back up to mass of KF. So we can't just jump from mass of KFO3 to mass of KF. We have to take some steps in between there to be able to get that done. So, when we've done this before, we've gone from mass of one thing to moles of something. When we do that, we use molar mass. So at this point, we'll be using molar mass of KFO3. To go from moles to moles, we have to use a mole ratio that compares moles to moles. Okay, so that's where mole ratios come into play. And then lastly, to go from moles to mass, we need to use molar mass again, but this time for KF, since that's the substance we're looking at. So we'll do molar mass of KF. Alright, so this is a diagram, a map, if you will, of where we're going. We're going to start here, and we're going to start with mass, then we're going to go switch it to moles, then we'll switch to moles of the second substance, and then back to mass. So let's do that. That's going to be part 3. Okay, so we're starting with 122.55 grams of KFO3. Now I strongly suggest you just go ahead and put that over 1, just to make it a fraction. We're going to be doing lots of conversion factors here, and it's going to make more sense if you have that over 1. It doesn't change anything now. So, we're going from mass to moles. So whatever unit we're starting with, we'll put on the bottom of the next conversion. So I'll put grams of KFO3 down here, and I'm trying to get to moles of KFO3, so I'm going to put moles of KFO3 up top. So, and I said right here, we're going to use the molar mass of KFO3. So that's this number right here, this 106.1. 106.1 grams is equal to 1 mole. So 1 mole of KFO3 is going to be 106.1 grams of KFO3. Okay? So that got us from mass to moles. So that's done. We've got that part done. Next, we have to go from moles of KFO3 to moles of KF. So we'll do another conversion. We're starting with, we've now moved to moles of KFO3, so we're going to put that on the bottom. That's where we're at now. Moles of KFO3. Hopefully I don't run out of room. And we're going to moles of KF. So we come over here and we look at the mole ratio. It's 2 to 2. So we have 2 moles of KF and 2 moles of KFO3. Remember, that came from our coefficients out front here. So that's where our mole ratio came from. So using a mole ratio, that's going to take us from moles of KFO3 to moles of KF. And so the last thing we need to do is go from moles of KF to mass of KF. So we're going to have one more conversion, and we'll put, since we're starting with moles here, I'm going to put that on the bottom, moles of KF, and I'm going to put mass of KF, or grams of KF, on top. And I need to use the molar mass to do that. 58.1 grams of KF is equal to 1 mole of KF. So I'm going to put the 1 on the bottom and 58.1 on top. And that is our conversions. We have one conversion, 2 conversions, and 3 conversions. Okay? So that was the most difficult part. Now we need to do the math to get us on the right track. So normally I would have another color here, but I don't know. Oh. Boom, blue marker. Okay, so step 4 on your paper says to multiply across the top and the bottom. So I'm going to put all my numbers that are on top, I'm going to write these down. So I've got 122.55 times 1 times 2 times 58.1. Okay, so didn't type that into the calculator yet, so I'm going to go ahead and do that. Times 1 times 2 times 58.1 gives me 14,240, 0.31. So I just multiplied these numbers across the top and got that. And I'm going to do the same thing on the bottom. I've got 1 times 106.1 times 2 times 1. And when I do that, I get 212.2. So, the last step, step 5, is divide the top and the bottom. 14,240.31 divided by 212.2. And if you type that into the calculator, you're going to get 0.2. It's going to give you a big string of numbers here, like 67.10796, and it keeps going. Okay? So, that answer right there is all the way back over here, the mass of KF. 67, hold on, let me see what it was again. 67.10796.418. At least that's for what I got on the calculator. Now, we're not going to write all those numbers out. We're going to do significant figures, which if you forget what those are, then just be happy with that number and we'll leave it be. Significant figures, we have 1, 2, 3, 4, 5 sig figs in our beginnings amount. So we're going to have 1, 2, 3, 4, 5 in the end, the answer. The 9, 6, whatever is going to round that 7 up to an 8. And that's our final answer. So if you have 0.55 grams of KFO3, then you should end up with 67.108 grams of KF. Now I know you're saying to yourself, why in the heck do we have to do all these problems? The idea is that this is used throughout all sorts of industries, all over the place, and it's important to understand what's going on. So, I hope that's been helpful. If you have more questions, feel free to contact me, and I'll be happy to help you. Have a good evening.